Hello, welcome to lecture 14. Today I'm going to talk about probability and Appendix 1 and Appendix 2 of Mathematics for Class 10, chapter number 15 and Appendix A1 and Appendix A2. This is based on NCERT syllabus. My name is Sangam Banerjee and my details are given below. So here I would like to request students to kindly go through my class 9 maths lecture number 14. This will help you in understanding the present lecture. So here probability can be obtained experimentally or also it can be obtained theoretically. So experimental probability is found by repeating an experiment and observing the outcome. That is, you can define this P is the symbol of probability of any event is number of times the event occurs divided by total number of trials, which was discussed in much detail in class 9. So example is, if a coin is tossed 10 times and if you get head 7 times and tail 3 times, then the probability of head is 7 by 10 and probability of tail is 3 by 10. But if you continue doing for more number of times, then it will approach theoretical value, which we will see in this present lecture. So theoretical probability is what is expected to happen. So here what is expected to happen. So suppose if you toss a coin, okay, you are expecting either it will be head or tail. So there are two outcomes, but one of the outcome is head and another outcome is say tail. So number of favorable outcome, that is head, is only one time, and total number of possible outcome is 2, head and tail. So probability of head is half, and similarly probability of tail is half. So this is the theoretical value of the probability of head, and this is the experimental value of probability of head. So if you do many number of time, this will approach to the theoretical value. Now for the case of dice, suppose you have on this phase 5. So suppose you do 1000 times you roll a dice and you get 140 times 5, then the probability of getting 5 is 140 by 1000. But theoretically you are not rolling the die, you are not doing experimental. So it appears that you have 6 phases, so 5 is only one phase, so it will be 1 by 6. So if you do this many, if you increase this number will approach to 1 by 6. So here in this we define something called elementary event. That is, in probability theory, an elementary event, also called an atomic event or sample point, is an event which contains only a single outcome in the sample space. Okay, so example is getting head or tail in tossing of a coin or getting a particular face of a die are all elementary events. So getting a head is an elementary event, or getting a tail is also, or if you roll a dice, if you get some number, each one is an elementary event. Okay, so here we now try to understand this theoretically. So what is the probability of pulling out yellow of this 3 ball is 1 by 3. Okay, there are 3 balls, so it is 1 by 3. Similarly, the probability of pulling out red out of this 3 ball will be 1 by 3, and similarly for the blue. So if you add these probabilities, that is probability of yellow plus probability of red and probability of blue is equal to 1 by 3 plus 1 by 3 plus 1 by 3, that is 3 by 3, that is 1. Now in case of coin, suppose you toss, the probability of getting head is 1 by 2. These are all theoretical values, and probability of tail is also 1 by 2. So total, if you sum these two probability, it should be equal to 1. So one can say that the sum of the probabilities of all the elementary event of an experiment is 1. This is the sum. Okay, if you add all of them, the probability will be equal to 1. So in other words, we can say that let E be an elementary event, that is P of E, probability of E, is nothing but 1 minus probability of not getting E. So like probability of head is 1 minus probability of tail, because this is probability of not getting head. So here one can say that probability of E plus probability of not E equal to 1. Similarly, for this case, you see example, probability of getting yellow plus probability of not getting yellow, and probability of not getting yellow is probability of red plus probability of blue, which you have to add it. So that is 2 by 3. So 1 by 3 plus 2 by 3 is equal to 1. Thus one can say that the event not E, that is I represent as E bar, is called a complement of event E. We also say that E and E bar are complementary events. Like probability of head is a complementary event of probability of tail. That is, probability of head is complement of probability of not getting head. So they are complementary event. Now some more rules. The probability of an event which is impossible to occur is 0. So which is not going to occur is impossible. The probability is 0. Such an event is called an impossible event. Example, getting 8 in a single throw of die, because die has only from 1 to 6. So getting 8 is impossible because there is no phase which contains number 8. So P of 8 is equal to 0. Similarly, the probability of an event which is sure or certain to occur is always 1. So which you are sure that it will occur, the probability will be 1. Such an event is called a sure event or a certain event. Example, probability of getting a number less than 7 in a single throw of die. So whenever you throw a die, definitely you will get either 1 to number 6. So number getting less than 7 will be 1. Next, from the definition of the probability of P of E, we see that numerator, that is the number of outcomes favorable to the event E, is always less than or equal to the denominator, that is the total number of all the possible outcomes. So here we can say that either the probability will be 0, suppose it is impossible, and suppose it's sure it is 1. So the probability will be somewhere between this impossible probability, that is 0, or sure event, that is 1. So we write 0 is less than equal to P of E is less than equal to 1. So from exercise 15.1, this is the exercise number 19. A child has a die whose 6 faces show the letters as given below. So a die, each face has some letter. So one face has A, B, C, another face D, another face has E, and another face also again has A. So what is the probability of getting A? Is asking, the die is thrown once. What is the probability of getting A? A will be 2 by 6 is 1 by, and probability of getting face D is 1 by 6. There are 6 outcomes, so it will be 1 by 6. Now the next exercise, suppose you drop a die at random on the rectangle region shown in this figure. What is the probability that it will land inside the circle with a diameter 1? So what will be the probability that it will fall in this circle, inside this circle? So that will be area of this circle divided by the area of the rectangle. It's very simple. So probability of landing inside the circle is, this is pi r square, area of the circle. This d by 2 is radius divided by the area of the rectangle, that is height into width. So here it is pi by 4. This is 1 meter. 1 by 2 is 1. The square will become 4, and height is your 2 meter and width is your 3 meter. So this is your answer. That is pi divided by 4 divided by 2 into 3. So 2 into 3 is 6. 6 4s are 24. So pi by 24. Next exercise. A lot consists of 144 ball pens, of which 20 are defective and the others are good. Nuri will buy a pen if it is good, but will not buy if it is defective. The shopkeeper draws one pen at random and give it to her. What is the probability that she will buy it? So since she knows that 20 are defective, that is 124 are good, so she will buy it with a probability of 124 by 144, that is 31 by 36. Just check your solution in your textbook. And she will not buy it, the probability is 20 is defective, so probability will be lesser than this one because there is less number of defectives. So more likely she will buy the pen with this probability, and she may not buy the probability with this. So this number, this is 5 by 36, which is smaller than 31 by 36. Next, refer to exercise 13 and complete the following table. So this is exercise 13. You have two dice here, 1 and 2, and you throw it, and this is the outcome of one of the die, and this is the outcome of the second die. So it can be either 1 1 or 1 comma 2, second die will be 2, or 1 3. So this is the space of all the events here. Please go through my class 9 lecture where I have discussed all this in much more detail. So now what is the sum of the two dice? It is either 2 or 3 or 4, 5, 6, like that, and maximum can be 12 and minimum will be 2, because the minimum number of dot on the die is 1 and the maximum number of dot on a die is 6. So 6 plus 6 is 12 and 1 plus 1 is. So what is the probability of getting 2? So this is 1 plus 1, this is 2. So you have only one probability among all these outcomes. So 1 by 36 is the probability of getting 1 comma 1. That is the sum. 3 will be, here is 1 comma 2 and then 2 comma 1. So there are two outcomes of this 36. So probability will be for sum 3, this 2 by 36. These again cut and pasted from your solution book. So please go through this and check whether you understand this. So for 12, again it is only 1, 6 and 6. So it is 1 by 36. 5 plus 6 is 11. So you have this one, 5 and 6, or 6, 5. So 2 by 36. And the maximum of the sum, that is 6 plus 1 is 7. 5 plus 2 is 7. 4 plus 3 is 7. So there are altogether 1, 2, 3, 4, 5, 6. So this is the maximum probability here of getting 7. Now with this we cover chapter 15. It is a very small chapter, and please go through my class 9 lecture also and just go through it, because once you know what I have said here, the reading the chapter will be very easy. Now we come to the next chapter, that is Appendix A1, that is proofs in mathematics. So what are the basic proof technique? Prove the statement P equal to Q. How do you do that? There is a direct proof. Proof by construction is also called. Then there is proof by contradiction. Then there is proof by induction, and there is proof by contrapositive or proof by contraposition. So these are either some mathematician use this word or some mathematician use this word. So let us see all these four with a small example. So prove that the sum of any two consecutive number is odd. Okay, any two consecutive number. 3 and 4 is a consecutive number. 17 and 18 are the consecutive number. So any two consecutive number, the sum of, if you sum them, it is odd. So to prove this, following three definitions are only required for our proof. So what are definition 1? An integer n is even if and only if. This is a symbol which we are going to use. There exists. This is the symbol for the an integer k such that n equal to 2k. Okay, so even number will be always some number multiplied by 2. Okay, so any number which can be divided, this number if it is divisible by 2, you will get one number k, then it is an even number. Definition 2, an integer is odd if and only if there exists an integer k such that n is equal to 2k plus 1. So if there is some number k, this is even, plus one more if you add it, it becomes odd. So every alternate numbers in natural number, 1 is odd, 2 is even, 3 is again odd, 4 is even, 5 is odd, 6 is even. So it's something like that. So you add one more, so it becomes an odd. So this is the definition of even number, and this is the definition of an odd number. And the third definition, two integer a and b are consecutive if and only if b equal to a plus 1. So since b is the next number to a, so b equal to a plus 1. Now we will prove this one by direct proof. Given if a and b are two consecutive numbers, then b equal to a plus 1 from this definition. So if I add a plus b, in both the side a, if I add, this a plus a will become 2a. So a plus b will become 2a plus 1. Thus there exists k such that a plus b is equal to 2k plus 1. So in this case your k is what? A actually. So a plus b is odd number. So this is a direct proof. Now in some cases this is a simple one. So but in some cases it's complicated to prove by direct method. You use proof by contradiction, which we will see as we progress in this lecture. So here to prove if a and b are two consecutive number. So this is one condition, that is consecutive number, this condition 1, and that is b equal to a plus 1. So if this condition is true, this will be obviously from the definition. Then a plus b is odd. Now by proving this by contradiction method, that is I now consider a plus b is even. I assume the opposite of this one. So if I assume that a plus b is even, then a plus b, I know that b is equal to a plus 1, which is given already. So these are the truth, and this we have to find out whether it is true. Okay, 1 and 2 are true statement, but this is asking whether it is true or not. So a plus b, b is equal to a plus 1. I substitute here from 2, I get 2a plus 1. So this implies that a plus b is odd. So my assumption is wrong. I had assumed that a plus b is even, but if I use this condition, I get a plus b is odd, thus contradicting the assumption, and hence a plus b must be odd. Just go through my also class 9 lecture and just think about it. You will understand as we go on. This procedure will be clear to you. And this appendix chapter mainly deal with this contradiction. Proof of induction and proof by contrapositive is not discussed in your chapter, but for the sake of completeness, we will discuss this in one slide. Now proof by induction. A proof by induction is to prove a statement about an arbitrary number n by first proving it is true when n equal to 1, and then assuming it is true for n equal to k, and show that it is true for n equal to k plus 1. So first we prove it for p1 for n equal to 1. So 1 plus 2 is 3. This is odd. So this is odd. So this is true. And I assume this pn equal to n plus 1. This is the number n. This is the consecutive number n plus 1. That is equal to 2n plus 1. That is pn is odd. So now if I substitute in n plus 1, k plus 1 I have written here, is immaterial. Show that it is true for n equal to k plus 1 and n equal to k. So I write p of n plus 1. So I substitute here everywhere n plus 1. Here also I substitute n as n plus 1. So I will get n plus 1 plus n plus 1 plus 1. Okay, this one. So you will get twice of, you just rearrange it, you will get twice of n plus 1 plus n. So this implies that this is an odd number because this is even. So any number multiplied by 2 is an even number because this number will be divisible by 2, because this 2 and divide by 2 will cancel, you will get that number. So this number plus 1, this even plus 1 will be odd. So p of n plus 1 is odd. Thus from the mathematical induction, pn is odd for all. So this is a symbol for all. So pn is odd for all integer n. Thus the sum of any two consecutive number is odd. So this was proof done by induction method. Now proof by contrapositive or proof by contraposition, as I said earlier, these are same, is a rule of inference where if A then B is given to you, I have to prove that it is true. So what you do is, then you construct a claim that if not B, then not A. So if B is not true, then A is also not true. That means if B is true, then A is also true. Okay, you will understand as I progress here. So symbolically you can write if A implies B, then by constructing prove the claim that not B, this is a symbol for not B implies implies not A instead. Example, if it is my car, then it is red is equivalent to saying if the car is not red, then it is not mine. So go through this. So this you will understand. Just pause and read it again. So how do you do the proof? By contrapositive or contraposition. Here proof. So here I assume the opposite, that it is not odd. So not odd means is even. Then there exists integer k such that since it is even, then a plus b is twice k because it's a multiple of 2. Now this 2k I can break into k plus k, and that is not equal to k plus 1 because k plus 1 is a successor of k. So since this number is not equal to this, so my this assumption is wrong. So a and b cannot be a consecutive integer if a and b is even. So if a and b is even, I will not get k plus 1. I will get k plus k. Okay. Just pause it and go through it again. Thus, if a and b are consecutive integer, then a plus b must be odd. Since this condition is, this not b implies not a. When not b is a plus b is not odd, that if it is not odd, then you know that it cannot be a consecutive number. So this is not a. So then that means if you take contrapositive, then if this condition is true, then a implies b. Here I would request students to read this chapter appendix 1, and with the present understanding, I am sure you can understand the chapter from your book. So here we'll only consider one exercise, that is A 1.6. The other exercises are very trivial. So I'm sure if you go through it, you will understand. So let us do this. Okay, now exercise 1. Suppose A plus B equal to C plus D and A is less than C. These are the two conditions. Use proof by contradiction to show B is greater than D. So first we'll do direct method, that is B minus D. If I bring this D this side and A this side, I get B minus D equal to C minus A, and C minus A, if I put this A this side, C minus A, so this is an open side, so this is greater than 0, so I can write this is greater than 0. That is equal to this. If this is greater than 0, then B minus D is also greater than 0. So if I take this minus D this side, I will get B is greater than D. So this is a direct method. Now proof by contradiction. Given these two condition or hypothesis 1 and 2 are true, okay, these are true given this, and assume that instead of B greater than D, I assume B is less than D because we are proving by contradiction. So we are taking an opposite of this, B greater than D, opposite of it is B is less than D. Then using this condition, this is given a truth condition, so A is less than C, then I can always write this is A plus B will be less than C plus D. Okay, this is left hand side you add it and right hand side you add it, and this is a common less than sign, you keep it here. So by assuming B is less than D, it contradicts this statement which is equal to, and here you got less than sign. So hence B should be greater than D. So this assumption was wrong. So B should be greater than D. Now exercise 2. Let R be a rational number. This is one condition, and let X be an irrational number. So this is another condition. This X is irrational number. Use proof by contradiction show that R plus X is an irrational number. So how do I do it? Proof by assume that R plus X is a rational number. Here it is saying it is irrational, so I assume opposite of this. This R plus X is a rational number. Then I can, if I assume this is rational number, I should able to write as a ratio of two integer, okay, A by B. So I bring this R this side, so I will get X is equal to A by B minus this R. R I can call it, since this is a rational number, I can again express it as ratio of two integer, and I call it C by D. So now these are all integers, and if I do cross multiplication, I will get X as a rational number. So if I consider R plus X as a rational number, I get X as a rational number. So this contradicts this statement too. X is an irrational. So here I have written the same thing what I have told. It implies X is a rational number, hence contradicts 2. Thus R plus X is an irrational number. Just pause and again go through all these exercises. Exercise 3. Use proof by contradiction to prove that if for an integer A, okay, for an integer A square is even, then A is also even. So is A even. So how do we do proof by contradiction? Here it is said that A is even. So I assume opposite, that is assume A is odd, that is it is of the form of 2n plus 1 for any integer n. So A square will be 2n plus 1 the whole square. So if I write expand it, I will get this. I rearrange it, I get this. So here you see this is your even number because it's divisible by 2 here. This factor is also divisible. So it is this whole term is divisible by 2. So this is even number plus 1 is an odd number. So A square is an odd, contradicting my point 2 that A square is even. So if I take A as odd, I will get A square also as odd. So this will contradict this statement. So A has to be even. It cannot be odd. So if I take A as odd, then I get A square also as odd. So to get A square even, I have to have A as even. So vice versa also. Here we have proof for the vice versa term. If A square is odd, then A is odd. So is a vice versa is also true. Here if A square is odd, so is A odd. Okay, here A square is even, so is A even. Okay, now exercise 4. Use proof by contradiction to prove that if for an integer A, okay, this is condition 1, A square is divisible by 3. If this is true, then A is divisible by 3. So these are the two hypotheses or condition, and if this is true, then A is divisible by 3. So how do you prove this by contradiction? Now I take the opposite of this, that A is divisible by 3. I take A is not divisible by 3, and then if A is not divisible by 3, I know that A should be written as either 3n plus 1 or 3n plus 2. If it's 3n plus 3, then it is divisible by 3, because 3 you can take it out common. Now there are two cases here, that is case 1 is A is equal to 3n plus 1, this is the one, and case 2 is 3n plus 2. Now we will see whether it is divisible by 3. So if it is not divisible by 3, which we can show here, if I substitute this value of A here, 3n plus 1 here, and I expand it, and I will see that I get some integers here and some fraction. And so since it has a fraction, it is not divisible by, is the sum of two natural number and a fraction, which is not a natural number. So this is not a natural number, because, and this is not divisible by 3 because the sum of these two natural number and a fraction is not a natural number. So it is not divisible by 3. With similar argument, I take A is equal to 3n plus 2 and I substitute here, and with similar argument I can show here that here also you get some integer and some fraction if I divide by 3. So if A is not divisible by 3, these two cases are not divisible by 3, then A square also we saw is not divisible by 3. So here I write, if A is not divisible by 3, then A square is also not divisible by 3. So we contradict 2. This is 2. Therefore A must be divisible by 3 for A square to be divisible by 3. Just pause it and go through it. Now exercise 5. Use proof by contradiction to show that there is no value of n for which 6 to the power n ends with the digit 0. So how do we prove? Let there be a value of n for which 6 to the power n ends with digit 0. Okay, again I take an opposite because we are proving by contradiction. So if it ends with 0, then 6 to the power n divided by 10 should be k, an integer number, and we know that 6 to the power n divided by 10 is equal to, I break this, 2 to the power n into 3 to the power n, and 10 as 2 into 5. So this 2 will get cancelled here with one of the 2 here, so it will be 2 to the power n minus 1 into 3n divided by 5. So now you have n minus 1 2's and n 3's. This is 3 into 3 into 3 n times, and this is 2 into 2 into 2 n minus 1 time divided by 5. So there is no common factor. So now it is not an integer. You will have some fraction. So therefore contradiction. So there exists no value of n for which 6 to the power n ends with a digit 0. So therefore 6 to the power n number doesn't end with 0. If it would have end with 0, then I would have able to divide it and get some integer. And here we see that we don't get integer. We get some fraction. Exercise 6. Prove by contradiction that two distinct lines in a plane cannot intersect in more than one point. So we know that two lines can either be parallel, or they will intersect at one point, or they will coincide. So here how do you prove? By contradiction proof. Two distinct lines A and B can either be parallel or intersect at only one point. Here I say superposition of lines are not distinct. They can be on top of each other. They are not separate line. It cannot be. So if one of the line A intersect the other line B, say at more than one point, then this line A is not a straight line because it is curved line according to the definition of straight line. So here it contradicts the definition of a straight line. So this is the contradiction here. Now negation of a statement. What do you mean by it? A symbol used to represent the negation of a statement is either this sign, like a similar sign, or this sign. Okay, so any one of them you can use it. For example, the given sequence, this is Q, such that this two dot means such that all teachers are female. Then the negation of the given statement is this symbol you have to put. The negative of this statement or negation of this statement is Q. So how do you negate it? It is false that all teachers are female. Here it says all teachers are female. Now you negate it by saying it is false that all teachers are female. Thus, if the given statement is true, then the negation of the given statement is false. So if this statement is true, like here all teachers are female, so this statement will be false because it is negating this statement Q. Okay, that's why it is written false Q. Okay, so this symbol you have to add before this. So in other words, let P be a statement and negated P its negation of this P. Then negated P is false whenever P is true. If P is true, if you make a negative of this or negate it, it will become false. And if negated P is true, then actual P is false. Just think about it, pause and think of it. Converse of a statement. So what does it mean? The converse of a statement, that is P implies Q, is Q implies P. So it is the other way around. If P implies Q, then Q also implies P. So this is a converse of a statement where P, Q are the statement. Note that P implies Q and Q implies as P are the converse of each other. Okay, what I have written here. So connecting two simple statements with the use of the word if and then. So if this is P, then this will be Q. And the converse will be this. Okay, so let us see an example. P is such that Jamila is riding a bicycle, and Q such that 17 August falls on Sunday. So here I can say a statement, this is P, Jamila is riding a bicycle, and statement Q such that 17 August falls on Sunday. So the converse is if 17 August falls on Sunday, so you have to bring this statement in the left hand side from right hand side. So how do you do it? If 17 August falls on a Sunday, then here I have written, then Jamila is riding a bicycle. Again I say pause it and go through it. Now mathematical modeling. This is taken from class 9 maths lecture 15, lecture number 15. Here I have just cut and pasted from this lecture. Here I have said mathematical modeling is the process of describing a real world problem in mathematical terms, usually in the form of equation, and then using this equation both to help understand the original problem and also to discover new features about the problem. It is used for prediction about the real world, to understand situation and to assist in making decisions. It is the bridge between the real world and mathematics. The stage involved in mathematical model are formulation, solution, interpretation and validation. So kindly pause it and you yourself read it again. And here I will not go into detail. Two examples are given here, and this has been just cut and pasted from this class 9 maths lecture. So I would request kindly students to go back to my class 9 lecture 15 and just go through these two lectures where I have shown how to formulate what is a solution and what is the interpretation. Or you can simply pause this and go through this, and it is self-explanatory. Now some points taken from class 9 math lecture 15. Here I say again, repeat it, the steps involved in the mathematical modeling. You have formulation, that is stating the question, identifying the relevant factors, mathematical descriptions, then after this finding the solution, then interpretation of the solution in the context of real world problem, and fourth is checking and validating to what extent the model is good representation of problem being studied. So when you do a problem which is exactly solvable, then you need not do the checking and validating, but sometimes some statistical problem you have to repeat it and you have to recheck it and then take the average value, and this is also called as validating. So here I show one flow chart, that is real life problem. You simplify, describe the problem in mathematical terms, solve the problem, interpret the solution in the real life situation, and does the solution capture the real life solution? If yes, model is good, is suitable. If no, then again change the assumption, change the model. So this is what is very similar, and this is what is written in terms of a flow chart. Now exercise from appendix A2.2. So here we will show how this word problem you model it and get the solution. So exercise 1, an ornithologist wants to estimate the number of parrots in a large field. She uses a net to catch some and catches 32 parrots. So she catches from the field 32 parrots, which she rings and sets free. So how many parrots she sets free? 32 parrots. She rings it, she marks it, and she sets it free. The following week she manages to net 40 parrots, and of which 8 are ringed. So this 32 was left free. Of that, 8 she catches next day among the 40 which are ringed. So what fraction of a second catch is ringed? So it is 8 by 40, that is 1/5. So this number 1 by 5 is like approximately density, that is 1/5 of the parrots in the field which were set free earlier are ringed, and find an estimate of the total number of parrots in the field. So this is easy, that is if 32 parrots have ringed in X number of parrots, so these 32 parrots were ringed by her, and assume that there are X number of parrots in the field and they have been spread homogeneously. So your density is homogeneous, so density is 1 by 5. So here it means density of the ringed parrot is 32 by X, because 32 ringed parrots were set free among the X, and since 1 by 5 of the catch have rings, so I can equate this 32 by X is equal to 1 by 5 because both are density, so I can equate both, and then I rearrange it. So X, this 32 X will go up, this 5 will go up here from denominator to numerator. So 32 into 5 will be your X, so X is equal to 160. Just simple multiplication, and repeat the experiment for validating. Solution will be average of X. So if you repeat, go on repeating it, because these are statistical things. Okay, sometimes she may catch less or more and then set free. In the next days she may catch again less or more than 40 and then she will count. So these numbers will change. So depending on this you get several X values and take the average of it. So you will know what is the number of parrots in the field. Next exercise, a TV can be purchased for rupees 24,000 cash or for rupees 8,000 cash down payment and 6 monthly installment of rupees 2,800 each. Ali goes to a market to buy a TV and he has only rupees 8,000 with him. He has now two options. One is to buy TV under installment because he doesn't have so much money. He has only 8,000 6000 rupees. So either he can buy under installment scheme, the scheme which is mentioned, or he can make cash payment by taking a loan from some financial or bank or some financial society. But the society will charge simple interest at the rate of 18% per annum, simple interest. Which option is better? Whether he should go and take the cash from the bank, 16,000 extra, and pay it, or he should go with the shops, 2,800 rupees each, this monthly installment. So let us see if he calculate this interest by paying this, how much interest is paying to the shopkeeper instead of going to bank. Let us calculate the interest. So here, this is formulation. TV costs rupees 24,000. While with installment, he has 8,000 and 6 installment of 2,800. He pays total of 24,800. So that is 800 rupees extra. So how much, what is the simple interest of this number? So I can do some little calculation. That is, first month simple interest is 16,000 rupees. This is rate of interest R by 100 and divide by 12 because it's 12 months. So for second month it will be, simple interest will be, this is your simple interest, 16,000 minus 2,800 because shopkeeper has already got 2,800. So of this simple interest R, and similarly it will go on till 6 months, and for 6 months simple interest is, this is the thing, 16,000 minus 5 into 2,800. So just go through it and see whether you can understand this. It's very simple. So the sum of this simple interest should be rupees 800, this 800 rupees which I have said. And so the sum of the simple interest, this total sum of the simple interest should be equal to this rupees 800. So how do you equate it? The sum of simple interest is, this is 1600. Then next month you subtract 2,800 from 16,000, you get this, and again you subtract third month, this for the fourth, this for the fifth, and this was into R by 1200, what I have written here. So you will get here 54,000 into R by 1200. Now these two zeros I cancel, I get 540 into R by 12. So that is equal to, this 12 will go 45 times. So 45 R, I'm equating it to 800. So therefore rate of interest will be, R is 800 by 45, which is 7.78%. So this rate of interest is smaller by the shopkeeper than going to the bank or some financial society. So the interpretation is that this is less than 18%. So Ali should go for the installment instead of loan. So now I think with this we have covered the whole class 10 mathematics NCERT syllabus, and here are some of my advices. So discuss with friends and share this lecture with your friends. Subscribe this channel to get updates. Send your comments, suggestion and doubt to my Gmail account, this one. Hope this series of lecture will be helpful in your understanding, but there is no substitute to practice. Whatever I have said, my main aim was to make you understand, but you have to practice. The more you practice, the quicker you can solve in your exam. Write your own notes by pausing and replaying the videos. Read the textbook and try to solve the missed example and exercise. I might not have completed all the exercises. The trivial ones I have skipped it. So assuming that you all can do those trivial things, only the one which I felt may be difficult for you, I have done it. You can increase the playback speed to 1.25 or 1.5 to save time. So you need not, suppose you want to revise it again, and you can again pause it, go back, and you can increase the speed so that you can save the time. All the best for your exams and endeavor, and encourage and motivate me by subscribing and liking this lecture. See you all again in class 11 maths lecture. So thank you. See you in my next lecture.